All right, factoring polynomials. All right, in order to factor this polynomial, you notice that it's not 3 terms like any quadratic that we typically factor. It has 4 terms. So because of that, I'll suggest you factor by grouping. Factor by grouping. Meaning that you put them each part into groups. So I can group together my first 2 terms here, x cubed plus 9x squared, and the second 2 terms is negative 9x subtract 18. Don't just drop parentheses right here. Actually put a plus and then negative 9x subtract 81. That way everything actually stays in the right place. And what you look for is the GCF between both of those. So GCF of x cubed and 9x squared is x squared. If you factor out an x squared, that leaves you x to the first plus 9. Here, GCF there, both of those are negative, and both are divisible by 9, so GCF is negative 9. So you factor out a negative 9, that leaves this one with a positive x, leaves that one with a positive 9. At this point, if you notice, is x plus 9 here, and there's x plus 9 there. Since both of those are the same thing, both of those come together. If we factor out both of those, essentially what you get is x plus 9 in one set of parentheses. And another set, you get x squared plus a negative 9 or subtract 9. So it's factored. Then you look to see if any of your factors can be factored further. You should recognize that as a difference of 2 squares. So because of that, it factors. Bx plus 3 times x subtract 3. And you still have x plus 9 here. So your solution is x plus 9, x subtract 3, and x plus 3. So that would be the perfectly factored form of that original polynomial. I'll get that as a note. So pause the video, write down everything, and when you get done, you should see some new stuff on the board, on the screen. All right, so in this new example, actually factor this trinomial. Considering what I told you last time, pause the video and see if you can factor it on your own. If you're not really sure, I'm about to explain it now. But again, if you think you can give it a shot, go give it a shot and pause the video. If you guys are not ready, this is how it goes. I group together the first 2 terms, and then I group together the second 2 terms, and now look for the GCF here. GCF here is 5. I'm sorry, x squared. If you factor out an x squared from both of those, you leave you x and subtract 5. GCF here is a negative 9. So you divide that by negative 9, you get x. Divide that by negative 9, you get subtract 5. Which is perfect because both of these are the same. So it comes to be one set of parentheses. And then the second pair is x squared, subtract 9. Which is kind of familiar. We just factored that. Give you x plus 3, x subtract 3. Other one is x subtract 5. So this is it. It is completely factored. One last example. Oh, we should get this as a note, but one last example. Factor the expression x to the 4th subtract 3x squared subtract 4. This is different from the last one. It's in quadratic form. It's in quadratic form. Meaning that the exponent here is twice that exponent. So because of that, we could treat it like a quadratic, as in we can use the x game. So I can use a negative 4 here, 3 comes here, you look for what multiplies to be negative 4, adds to be negative 3. That's negative 4 and positive 1. So your factors ordinarily would be x subtract 4, x subtract plus 1. However, because it's to the 4th, this should be x squared, and that should be x squared. If you fold both of those together, you get back to where you began with. So these are your factors to it. If you check see if your factors are done, this is factorable. The factors be x plus 2 times x subtract 3, x subtract 2 times x squared plus 1. So it's x plus 2, x subtract 2 times x squared. Let me make that look better. Times x squared subtract plus 1. And again, if you're not sure, take that, fold it together. See if it gives you what you began with. You ought to find that it holds true. So again, whenever you see these exponents, one exponent behalf the other, you can factor that as a quadratic. Just keep in mind it should be squared there, or whatever half that is. If it was to the 6th power, it would be half of it here and here, so forth. All right, let me give one last example. The last one is this. It's quadratic form because this exponent is half of that one. So I'm going to use the x game. To get 1 and give you -2 is -1 and -1. So your factors are, you would say x subtract 1, x subtract 1. However, it's always half of this exponent. This exponent is 1 there. It's understood to be 1. So it's 1/2 here. Instead of 1/2 there. It generally always matches the middle exponent. Anyway, that's it. It's been factored. I'll explain it more tomorrow if you still don't get it, but that's it. That's all I have. Good luck.